Hello and welcome to helpyourmath.com. In this video, we are going to take a look at the sum and difference formulas. Each trigonometric function has its very own sum formula and its very own difference formula, and we're going to take a look at each one, starting with if we have sine of u plus v. And sine of u plus v is the same as sine of u times cosine of v plus cosine of u times sine of v. Next up, we have the difference formula for sine of u minus v, and that would be sine of u times cosine of v minus cosine of u times sine of v. Moving on to cosine, the sum formula for cosine, where we have cosine of u plus v, will be cosine of u times cosine of v minus sine of u times sine of v. Cosine of u minus v will be, oddly enough, cosine of u times cosine of v plus sine of u times sine v. Moving on to our tangent formulas, the sum formula for tangent of u plus v will be tangent of u plus tangent of v over 1 minus tangent of u times tangent of v. And our difference formula for tangent of u minus v will be tangent of u minus tangent of v over 1 plus tangent of u times tangent of v. You need to ask your instructor if you need to memorize these formulas or if you can have a formula sheet or have these on a formula sheet somewhere handy. But what we're going to focus on is being able to apply them. So we're not going to memorize them right now. We're just going to look at applications of applying these. And you might be wondering, like, why would we need these? And this would be because we know a couple very specific trig functions for angles, certain angles, right? So like the most common are the ones like pi over 3 and pi over 6, or 60 degrees and 30 degrees, and the multiples of those, because those are the ones that we see the most often. They appear on the unit circle. And there's many other angles on the unit circle and you know, in trigonometry where we could write them as a sum or difference of our friendly angles, those angles found on the unit circle. So let's take a look. So in our first example, we have sine of pi over 3 plus pi over 4. And if you actually added those together, that would be sine of 7 pi over 12, which is not one that we necessarily know. But if we break 7 pi over 12 up into pi over 3 plus pi over 4, this is something that we can actually evaluate. In this first example, we see we have the sum formula for sine, and we're going to assign u is pi over 3, and v is pi over 4. And we're just going to translate what we're given into the formula below. So I'm going to say that sine of u plus v is going to equal sine of u, pi over 3, times cosine of v, pi over 4, plus, I'm going to run out of space here, aren't I? Cosine of u, pi over 3, times sine of v, pi over 4. And these are things that we can handle, right? So it looks like a lot, but really we know, hopefully, that sine of pi over 3 is root 3 over 2, times cosine of pi over 4 is root 2 over 2. And if we multiply those together, that becomes root 6 over 4, right? We're multiplying, so we actually multiply the two 2's. And if we simplify the second term, we have cosine of pi over 3, which is 1/2, times sine of pi over 4, which is root 2 over 2. And then the second term, we have root 2 over 4. Good thing I do have that common denominator, because now I can add the square root of 6 plus the square root of 2. They are not like radicands, so I do have to leave them separate when adding, and I just get root 6 plus root 2 all divided by 4. And that would be my final answer, my evaluation of sine of pi over 3 plus pi over 4. So maybe I come up here and I just put my final answer, root 6 plus root 2 all over 4. Okay, and in our second example, we're going to apply the difference formula for sine. This time, we're going to call u pi over 4. And this time the order really does matter, right? Because we do have pi over 4 being subtracted by pi over 6. That makes v pi over 6. And again, we're going to write out the formula and simplify from there. So first up, we're going to say sine of pi over 4 times cosine of pi over 6 minus cosine of pi over 4 times sine of pi over 6. Can I squeeze it in? Barely. Okay, sine of pi over 4, that's root 2 over 2. Cosine of pi over 6 will be root 3 over 2. And then if I simplify this, I get that root 6 over 4. I am going to multiply, I won't forget. Here we're going to subtract, and then our second term, cosine of pi over 4 is root 2 over 2. Sine of pi over 6 is 1/2. And so we're going to subtract this by root 2 over 4. Now I want to actually subtract. I already have a common denominator, so that's wonderful news. But I can't actually take away root 2 from root 6. So I'm just going to say root 6 minus root 2, all divided by 4. And that would be my final answer for this second question using the sine, sum, and difference formulas. In this case, the difference formula. All right, so far so good. Let's keep going. In our next examples, we're going to look at the cosine, difference, and sum formulas, starting with the difference formula. And actually, if we put back together these two pieces that are inside the cosine, so if we find that common denominator, it would actually be 6, right? Because we would multiply by 2. We would have 7 pi over 6 minus 2 pi over 6. And what this is cosine of 5 pi over 6, which we actually know, right? We can determine the value of cosine of 5 pi over 6 as one of our friendly ratios. And it terminates in quadrant 2. The reference angle is pi over 6. Cosine's negative in quadrant 2. And this ends up being negative root 3 over 2. So now we're going to verify that the cosine difference formula actually works because we kind of already know we definitely know what the answer already is. With cosine, let's start labeling. We're going to have u is 7 pi over 6, and v is pi over 3. And let's go from here. So we have cosine of u, cosine of 7 pi over 6, times cosine of v, pi over 3, plus sine of 7 pi over 6, times sine of pi over 3. And again, we have all these friendly angles to work with. We're going to use that reference angle theorem or the unit circle to help us evaluate each of these trigonometric values. Cosine of 7 pi over 6 terminates in quadrant 3, where cosine is negative. Reference angle is pi over 6, so it's negative root 3 over 2, times cosine of pi over 3, which is 1/2, plus cosine of 7 pi over 6, that is still going to be negative because sine is negative in quadrant 3. That would be negative 1/2, times sine of pi over 3 will be root 3 over 2. And we're going to simplify each term and then combine them. This becomes negative root 3 over 2 times 2 is 4, minus, because there's that one negative of the three term, the plus and then one negative and one positive, and we get root 3 over 4. Negative root 3 over 4 minus root 3 over 4 is negative 2 root 3 over 4. We actually can combine the radicals because they are like radicands. And this becomes, when we simplify 2 over 4, negative root 3 over 2, which is what we were expecting, right? So the formula holds up, which is great news because it'd be terrible if the formula didn't work. In this next example, we have the sum formula for cosine. And I'm going to label u as 5 pi over 6 and v is pi over 4. And so again, really what we're looking for here, the common denominator is 12. This is not a friendly one. This is 10 pi over 12 plus 3 pi over 12. This is looking to evaluate cosine of 13 pi over 12. Okay, so we actually need the formula because I can't do this by using the unit circle because we don't have denominators of 12 on the unit circle. So let's take a peek. We're going to use the sum formula. We're going to say cosine of 5 pi over 6 times cosine of pi over 4 minus sine of 5 pi over 6 times sine of pi over 4. And we're going to evaluate each one separately. Cosine of 5 pi over 6, that terminates in quadrant 2 where cosine is negative. We're going to get negative root 3 over 2 times cosine of pi over 4 is root 2 over 2. Minus sine of 5 pi over 6. Well, sine is positive in quadrant 2. So we get, minus positive 1/2 times root 2 over 2. Cleaning up our first term, I multiply root 3 by root 2 and I get the negative because there's one negative, root 6 over 4 minus root 2 over 4. And now I don't have like radicals, so I just kind of leave them separate. Negative root 6 minus root 2 over 4 would be my final answer here for this sum formula for cosine. I'm just going to write it negative root 6 minus root 2 over 4. And in these last two examples, we will just condense this into kind of like work backwards here. So we're given the output and we want to write what the input was. Starting off with the first one, we have cosine of alpha over 3 times cosine of alpha over 6 plus sine of alpha over 3 times sine of alpha over 6. Given that the cosines are in one term together and the sines are in another, that sounds like a cosine difference to me. So that kind of matches up with this one where we have u is alpha over 3 and v is alpha over 6. And so we can write this as cosine of alpha over 3 minus alpha over 6. And then let's take it one step further. Let's actually subtract. If we're going to subtract these two fractions, we would need a common denominator, and that would be 6. So I'm going to multiply this u by 2 over 2. And so I'm going to say my final answer is that we have cosine of, that's 2 alpha over 6 minus alpha over 6. We're going to get alpha over 6. And that would be my final simplified version of this first example. For the second one, we have sine of 7 beta times cosine of 2 beta minus cosine of 7 beta times sine of 2 beta. This looks like one of our cosine formulas, specifically the difference, where u is 7 times beta and v is 2 times beta. So we're going to write that this is sine of 7 beta minus 2 beta, and simplify that because we can subtract those. We get sine of 5 beta. These have been examples of getting comfortable with the sine and cosine sum and difference formulas. Thank you for stopping by.